So, welcome everyone again. Today, we are going to talk about 40 principles. And as usual, we started with a quote. In this case, we chose a quote of "Solution have a voice. The problem is knowing to listen, how to listen." And this is what 40 principles, in a way, helps to listen for these problems, for these solutions, and find these solutions. And of course, as usual, we structure it in a way that we're not diving too much into the theory of how to use 40 principles in general and what 40 principles are. We're concentrating how to use them within the PRIZ Guru platform. And for whoever is new here, PRIZ Guru platform is basically an infrastructure for continuous problem solving and innovation. Also, if you need to stop me at any point in time, please do ask any questions. Happy to answer. Now, the 40 Inventive principles was introduced in about early 70s by Gerhard Schuler. And his ginormous study that he conducted over 20 years, at the very beginning of it, he said something very simple. A vast majority of problems that require inventive solution typically reflect a need to overcome a dilemma or trade-off. Right, so basically, any decision, any problem that we're working on, typically, if you think about it, this is the reality. We're doing something at the cost of something else. And we will talk about that in a moment. Now, his biggest study that actually continued close to 20 years, he analyzed hundreds of thousands of patents, right? And these patents, he said something very simple, that all of these problems and patents, problems that have been solved in patents, that's basically an example of a different solutions and how people solve these problems, how they approach these problems. Anatoly, you want to add something here?
Yeah, exactly. He said each problem, each patent is someone stuck with a problem, found solution and documented it. And we're lucky we can learn, but we can learn not from different patents. What he did, he classified it and make systematization of the patents and learned a lot about how people think and how people solve problems.
So as a result of this ginormous study, again, it took about 20 years, almost 20 years, and hundreds of thousands of patents, he came to a conclusion that any parameter that we're changing in the system or in a system that we're working on can be classified within the 39 general parameters or conceptual parameters, that how officially it's called. The second thing is the solutions of these engineering contradictions. So we'll talk about the contradiction in a bit. These solutions are very typical, and they also can be generalized and classified. In the connection between these two, the parameters, the contradicting parameters in the conceptual solutions, he built it within a matrix, and that's what's called the Schuler matrix, that connects between the two parameters that we're working on, or one parameter that we're trying to improve, and another one that getting worse. And he created a connection in the form of a matrix, so we can find it easy. How do we get from the problem to the potential solution, or to the guide to the solution? Now, the overall flow, if we trying to look at this in a simple way, the overall flow of 40 principles is, once we have the problem analyzed for ourselves and we define the problem for ourselves, we're getting a specific problem. Now, traditionally, a lot of people will say, okay, well, let's try something, let's do brainstorming, maybe some solutions that we already know will work. And they end up in trial and error. Trial and error, as we know, it's very expensive, it takes time, and it doesn't necessarily even solve the problem. So instead of doing that, from the specific problem, we move and we abstract the problem out. We look at this much more holistically and how we can generalize the problem. And we're doing that for one reason, so we can find an abstract or the conceptual solution. Once we found a conceptual solution, now we can adopt the solution to our specific world, to our specific case, and find the problem, the solution this way. Anything to add here, Nico?
No, it's okay.
Cool.
Okay.
As an example, we can take an equation that we all know. If we try to solve this equation by trial and error, we can probably do that, but it will take us ages, years. I don't know, maybe strong computers can do it today a little bit faster, but still it's very, very wasteful. Instead, what we do, we generalize and we find a well-known form of these type of equations, right? Without any specific numbers, but a generalized way, a conceptual way how we can represent this problem. Then we have a solution, a set of rules how we solve this type of problems or these type of equations, right? And that is the generic solution. And once we have that in hand, then we can find a solution pretty fast. Right. It's a simple example, but it emphasizes exactly what it means. Any questions until now? Okay, we'll move on. Now, what is parameter? Let's try to answer the question of what is parameter. Well, first of all, we always, as an engineer, we always work with different parameters. And here's an example of projects that we may or may not conduct. It's safety improvement, yield improvement, equipment availability, processes, whatever it is out there. If you think about any project that you're trying to improve, make better, at the end of the day, we're working with parameters. We're trying to deal with parameters, right? But what is parameter? And I'll ask the audience here. What do you think parameter is?
Sergio, what do you think?
Yeah.
Sorry. Can you hear me?
Yeah,
Yep.
sure.
Okay. Sorry, because here is so hot that I can't turn my camera on because you see a almost naked man. A parameter is a particular aspect of the problem that is affected by the proposed solution. You say you want to improve something, a specific parameter, doing a specific action, and something else generally deteriorates.
Right.
Okay.
But we try to, first of all, answer what is the parameter? What is that thing that we're trying to improve or something deteriorates? What is the parameter? And as usual, as many times happening, we're going to right to the basis, to the definition. And it appears that the definition of parameters is not that straightforward, right? And that's, by the way, one of the simplest definitions that we found, and that's from Cambridge Dictionary. So a parameter is a set of facts or a fixed limits that establishes or limit how something can or must happen or done, right? It's not very trivial sentence, to say the least, right? But if we think about it, the way that we can simplify it's parameter is almost a set of rules by which a system works. And by the way, when I'm talking about system, it could be engineering system, it could be system of human beings. It doesn't matter. It's still a system. And we can think about it as a set of rules how that particular system works. That is the parameter. So if we basically changing a parameter, this is we can claim at that point that the system will change its behavior.
Is it like game mechanics in a game?
Yeah.
A bundle of specific rules, and if I change one of these rules, for example, the duration, the action can take more or less time, then that affects the whole system. First a special thing, and then the whole system.
Mhm.
Yeah, you definitely can say that 100%. So
should be something measurable. It's not mentioned in this definition. It should be something that characterizes a specific aspect of the system behavior, and it must be measurable.
Excellent, excellent. And I thought about this, and I found everything we do, it's actually measurable somehow. This is very, very good, Yuli. Thank you very much. It's
thank you.
Yeah.
Also, we can treat.
Sorry.
Yeah, go ahead.
Yeah. So if you go to the root of the word parameter, so parameter is from the Greek, which is beside. So it's beside the measurement, right? So, and it probably you can understand parameter better by comparing with a variable, right? So a variable is something that in a model you have that could take any value you want. But a parameter is something that once you have fixed it, it determines the behavior of the system. So it's not necessarily that that's something that changes all the time, but it's something that you need to set to a value to determine the behavior of the system.
Okay, excellent.
Interesting.
Thank you.
Interesting. Okay. So thank you for all the input. Sorry, I clicked on the wrong thing. So when we're working with parameters, we always talking about, we can talk about this as connected parameters. When we change one parameter of a system, we're trying to improve one of the parameters of a system, we will always compromise on some other one or more parameters. So we'll do something better. Let's take a car, for example. We want to go much faster, which is great. We're changing the speed of the car, but we will waste more gas as a result, right? A simple example, and everywhere we look, we will see exactly the same pattern over and over again. Now you can look at these as a connected parameters because, traditionally these type of problems solved by compromise. Basically, the company will say, well, something is very, very important for us and we need to improve yield, right? We can pay for it, that's okay, right? So at the end of the day, instead of actually solving the problem, it's a compromise, a trade-off, and the problem is not really solved, right? We're just paying for it. Now, in order to solve it, we need to basically break that connection and disconnect these two parameters so we can change them. Without affecting each other. We can play with them as much as we want without affecting each other, right? Then we can actually build something innovative and build intellectual property. Questions here?
So I would say it's the most important. Each time we are going to solve to improve something, we should find what is going to be worse and find connection and destroy this connection. This is a way to solve problem. And this is what 40 principles is good for.
And by the way, in my experience, many people solve problems, not solve problems. They don't even think about anything else that's going to get worse. They will know about it after that, after the fact. And I'm coming from software. In software world, somebody fixes a bug, creates a feature. The feature itself works great, but everything else can collapse, and that happens over and over again.
I see Sergio and Eduardo is writing comments.
Oh,
please tell it, say it. No problem.
I simply like the definition from Juan that motivates the definition of parameters for mathematics, and I like that definition. I do also would like to stress, I think that in PRIZ, I think is not stressed enough that the contradiction between A and B arise when you choose I call method, a way to improve A. That's the cause that deteriorates B. A contradiction doesn't, in my opinion, it's not, I'm not the owner of the truth. In my opinion, any contradiction arises when you try to change something. And an inherent contradiction inside the system, it comes from a method that was implemented to solve in the past a specific problem that improved the parameter and deteriorated another, or it deteriorated the value of that parameter. That's in physical contradiction. That's my opinion.
Okay.
Yeah.
Okay. Eduardo, could you explain what did you mean?
Yes, thank you. I was just reacting to what is written at the end of the picture. It says to solve a problem means to eliminate a contradiction. Certainly, as long as you know the cause of the problem first. Because if you don't know the cause of the problem, how are you going to fix it?
Sure, that's part of the process how we even finding the contradiction without finding correct contradiction, right? Because if you the contradiction is typically found to solve a particular problem, and of course, in order to even start solving any particular problem, we need to define this problem correctly. So it's way the definition of a problem is way before we even dive into this tool, and it's absolutely correct.
You know, we have here a kind of hidden assumption that we know exactly what is A and what is B. But in real life, when you want to improve something, you not always know what B is in this situation. So what is the way to identify the B?
Exactly.
Okay, we will show you.
Okay.
It's not trivial, right?
In my modest opinion, as I said, B is not identified since you list I call the method, I call bullshit solution. That means something that really improve A, but unfortunately deteriorates B. I call it in Italian idea cazzata, because cazzata, that can be translated in bullshit, it's the word that generally is used to kill the idea.
Oh,
but I say you
love
need
it.
an idea to improve A, even if it deteriorates B, because it clarifies a contradiction. That's my way of working.
I love this definition. Amazing.
Okay, very good. Yeah.
cool.
All right, let's move on. So now we're coming to contradiction. And first of all, there's three types of contradiction. There's an engineering contradiction, the one that we're going to talk about today. There's physical contradiction and managerial contradiction. Again, here we're going to talk about engineering contradiction specific. And now the contradiction, in order to find contradiction, one of the tools to find contradiction is actually to build this fairly simple sentence, which is not always simple to build, as everyone noticed, but it has to have this structure. If, then but. if we do something, if we change something, then one of the parameters improves, great, but something else is worsening, something else getting worse. Great. Questions here? Anything to add?
No, that's okay.
Yeah, so there could be a number of things that could raise us getting worse, but the important thing is you need to find the one that will prevent you from doing A in the first place. You want to do A because it's good, but you're not allowed to do A because something is bad enough to become this B, right?
One of the ways to find the but is talk to managers, because managers' mind is like, yes, but
Okay.
it's actually something that I've seen in the form of a joke in one of the articles, but it is very true when we talk about different problems and solutions, especially in a group, especially people who try to think in a different way. This is where many times the but is coming from, right? Not necessarily from your own thinking. Your own thinking is great, but this is the group thinking a lot of helps a lot of times, right? Especially if we're talking about very complex systems. Somebody might know something that we don't, right? And if we change the parameter that we think in our own little world, in our own scope, that everything is fine, it's not affecting anything, it might affect another part of the system, something that we not have been aware of, but other people are.
Okay, Eduardo is writing, as long as then really improves. This is actually our willing. If we do something, if we eat more, we improve our weight. Yeah, but our movement will be difficult. This is, yeah, you're actually right. Yeah.
Oops.
Okay.
Right, we'll move on. So 39 parameters that Altshuler generalized, or that these are the 39 conceptual parameters. That's, if we search for internet, this is what we're going to find, with different explanations for them and different, different explanations for them in different forms and shapes. But the parameter is going to stay the same. And these are the parameters that we need to match from our specific parameter. We need to try and match or categorize or classify our specific parameter into one of these. Anything to add here, Anatoly?
No, it's okay. Let's move.
All right. So once we have our two parameters in hand, now we can dive into the actual Altshuler matrix that I was talking about. And let's take for an example that, and by the way, these matrices, we can find a bunch of them across the internet, and again, in different forms and shapes. This is just a nice looking one. And let's assume in our case, for whatever we're working on, the improving parameter is 15. This is how it worked out to be. And the worsening parameter is 31. And the matching principles based on this matrix is actually 21, 39, 16, and 22. Now, it's important to remember that the order of these principles that they listed here is very important, right? But what does it mean? It means that from his study, from these hundreds of thousands of patents, similar problems or similar conceptual problems being already solved, and we can use their conceptual solutions to try and find the solutions for ourselves. I'll stop here for any questions. And there is something in the chat.
No, okay, let's.
Okay.
Alex, I am Hemant Pardikar from India.
Yeah, welcome.
So first time I'm joining. Once I spoke with Anatoly, but that time my camera was not working.
Okay.
Yeah, we had a bilateral meeting that time. But the question that I want to ask
Mhm.
is that this is more statistical rather than any mathematical. Is that right?
That's a
These are the
statistical analysis. Yeah.
the most likely principles which are used.
Right.
Right.
Is that right?
So it's the
I
most
call-
likely principles that they used for these particular pair.
A pair.
Yeah.
For this part. So which also means that probably this kind of pair can be solved by some other principle as well.
Of course.
Right.
Of course. But the purpose of this is to limit our thinking, to limit our scope of thinking
Yeah.
to something much smaller. Because if we're going to start thinking about everything, we're just going to come right back to brainstorming and trial and error and a bunch of waste of time.
Yeah,
Right.
I'll just
This whole-
take 1 minute of yours on this.
Sure.
This is, brainstorming is like treasure island method. On an island, if there is a treasure and you have no map, how do you find it? You dig it
Exactly.
from one
That's a good
corner
point.
systematically somewhere, you'll get the treasure. What this matrix does is, it only restricts the area which has to be dug up in the treasure island.
Mhm. It's a very
Right.
good point. It's a very
Right.
good point.
Right.
Great. So, well, let's move on. The 40 principles. Yeah, so these are basically the pointers for principles that we talked about. And now these are the principles, and the principles are the conceptual solutions that have been repeating, the conceptual solutions that may potentially be applied for our use case to find the actual problem. This is where we're focusing about how can we use segmentation, for example, for our particular use case. And by the way, the order of these principles are very, very important. What it means, if we disregard the use case and disregard the pairs of parameters that we working on and that we found, statistically, it was found that the most used principle is actually segmentation across the board and so on. So this is the most used and this is the least used out of the 40, right? I'll stop here for questions.
Yeah, I just want to add that I know I have some friends, they don't like to use metrics. They said we always start to think about solution, moving from the segmentation down. And one of my friends said, I never got down to nested door. He said he always found solution using first 7 principles. You know what nested dolls is? It's matryoshka. When you place one doll inside of another doll, it's douche instead of one nozzle. It's this is also a way. The main idea is to be focused on something. When we try to think about everything, we got nothing. When we focused and think about something very specific, we do find solutions. And I did it a lot of times. I saw how people did it, and it's very, very it's worked well. Said, would you like to say something? Said?
Yes, hi.
Yes, please. Hi.
Hi.
Nice to
Yeah.
see you.
What I was just saying was that I can't make my camera. I can't make my camera, but anyway.
Yes,
I
okay.
remember you. I remember you.
Yeah, I'm trying to make my camera working, but it just doesn't let me. But anyway,
That's
what
good.
I was saying over there was that I always think of these as like clues or hints.
Mhm.
Like when you're a police, detective, you want to solve a crime or something, you're looking for some clues. So
Right.
you would think, okay, is segmentation would do the job for me? Of course, after those, you know, the matrix looking at the row and the column, you find like 4 numbers. Those 4 numbers that are represented here, I look at them as clues and then try to think if segmentation is going to help me with extraction or whatever it is. So that's what I wanted to say, like looking at them as clues and hints. You know.
Thank you.
Yeah. Right.
Excellent.
All right. If there is no any other questions, we will move to the
No,
actual example.
William also wrote William.
Sorry, William and Sergio, you want to add something?
No, just I think it's out of topic because the matrix is, despite the fact that some PRIZ master told me that the matrix had been classified by Altschuler later in time, the worst error in PRIZ, even, but I think that it's a useful tool despite this reported speech from Altschuler. And but I think that there are many bad use of the matrix and not enough discussion about some strange behavior, some strange structure of the matrix, just like why it's not symmetrical and why, for example, there are several, but I don't want to eat all the time of this meeting. I think it's just out of the topic. Maybe if someone wants to stay for.
In fact, I also, what Serico was saying, I also heard from one PRIZ master saying that Altschuler says it was one of his big mistakes to latch onto this matrix for a long time. And then later on, he discarded it.
Well, maybe it's something that more studies need to be done.
That's interesting.
Anyway, Daryl Mann is very very much attached to the matrix. I think he made a new matrix 48 by 48. So
I think that might, obviously we need to listen to the latest ideas of Altschuler, but I think as a way of teaching PRIZ, it's a very good introduction.
Yep.
Yeah.
Right. William, you wanted to tell something about 40 principles and parameters.
Yeah, so
yes,
I always
please.
explained the 40 principles to engineers as ways or concepts to make changes or to spark ideas. And a lot of engineers would say, oh, I only use 2 or 3 of those principles. I didn't know there was a list of principles. So I said, print this out, put it on your wall. And the 39 parameters are what designers and engineers can change that they didn't know they could change. And that's kind of how, and I said, print that list out as well, because that just sparks ideas. Yeah, using the matrix helps as well. But, you know, if you're not going to get anything from a presentation I do, print these 40 principles and 39 parameters and post it on your wall. That's just my comment.
Okay, thank you.
Okay.
Thank you.
Great. So let's move on, and we'll move on to the actual tool and how we organize that in the tool itself. So back to the platform itself. This is the platform interface if people, for whoever didn't see it before. We already created a project for this particular example. And we actually did analyze it in one of our blogs, if I remember correctly, but wanted to do it basically on the fly. And the problem that we're trying to solve here is the fact that the trap shooting, whoever is loving or seeing this sport, the result of trap shooting is this, right? It's a lot of dirt that we creating as a result of breaking these targets. You know, it falls on the ground, it stays on the ground. What do we do with that? how can we clean it up?
Make it out of ice?
Oh, yeah, very good. But again, you are trying to jump into solution. Now you will see this is one of solutions, but there are much more.
Right.
Yeah.
Yes, of course.
Right. And of course, one of the steps we need to define what the problem statement, right? And we'll talk about specifically about how to define problem statements in probably one of our webinars, and we have articles about that as well. But at the end of the day, what we're trying to do here is
just a moment, Alex. Problem statement page is the best place to think about contradiction. When we describe this current situation and we describe disadvantages, we already think about what could be, how can we improve it, what should be improved, and what could be disimproved. This is already way to think about problem and contradiction. Okay.
So, well, if you think about that, anywhere throughout the project, anywhere where you force to write and think and rethink the problem and rethink the current situation, of course, it forces you to think and rethink again. Any step of the project, any step of the way will force you to do that. And of course, it's beneficial for going forward, especially if we're doing it in a group where people contributing different details, I'm not talking about brainstorming, generating solutions and fire different random solutions out there. I'm talking about working together towards a particular goal and gathering more information for that, right? Same for problem statement. We gathering and discussing the problem statements many times as a group, and that helps a lot to generate more information. Not necessarily solution at that point, but more information about the particular problem and problem statement that we're trying to solve. So without further ado, for that problem, we will create an instance of a tool for 40 principles. And the way that we organize that in the platform is, first of all, here's our problem statement that is always visible in here. But to make us a little bit, to make us think about contradiction a little bit easier and faster, we said, well, what's the best known solution? And this best known solution could be as crazy as we want. It doesn't matter. It doesn't matter if it's feasible. It doesn't matter if it's, if we want to go up to space for whatever solution we want, let's do that, right? So it's a way to put us in a situation like, yes, we do know how we can solve it, disregarding of why not to do that, or why would something prevent us from doing it, right?
Okay, I propose in this case, use some special technique to collect the targets, debris from the field. Use some special technique.
Okay.
Some special technique. Okay.
Oops, I can't spell today.
For example, when we are in my hometown where we collect olives from the olive trees, we put a canvas on the ground before we shake the tree and the olives fall to the ground. And then we just get rid of the canvas, right?
Okay.
The broken targets.
Yeah, broken targets. Okay. So some technique is moving and collecting. Okay.
So again, at this point, it doesn't matter what we really come up with. Again, it's one of the tools that will focus us about this particular way of solving the problem, right? But again, remember from the previous from the presentation, if we're doing something, something does get better, but something else get worse. And the idea is to find that worsening part, right? So we get into the to the point of the building the contradiction. And building a contradiction, if you remember from the deck, we have this very specific structure: if, then, but. So if we, I can
if all
rewrite
splinters,
it.
if false splinters will be collected.
If we collect
all
the pieces,
yeah, with a special technique, yeah, then the field will be clean, the territory will be clean, right? This is a parameter that is going to be better, but this technique, it can destroy the soil.
Okay, so in this case, we might think about technique or some machine that will collect it, but the machine may or may not destroy the field.
Mm-hmm. Yeah.
The field.
Mm-hmm. Okay.
All right. So whatever the contradiction is, again, we can talk about how to find these parameters using a little bit different tool, what Anatoly mentioned, and there are ways to find those. And there's a comment from somebody. Yeah, Eduardo, solution must address to solve the problem. Yeah, you wanted to expand on that?
Eduardo must have, okay, I see. So let's
actually,
move. Okay,
actually
Eduardo.
we can say
yeah.
Actually, we can say that the worsening parameter is that it takes a lot of time and effort to clean.
Oh, we still not get there. We will on the way there. Alex,
sure.
Let's move.
Okay.
Oh yeah. You mean that it could take a long time? Yeah, it's but this is another contradiction. We picked up this
again.
One. We can if we have time, we can try another one, another contradiction. Yeah, sure.
Yeah, but in general, like we said before, some improving parameter may cause one or more parameters to be degrading, right? And in this case, again, it could take more time. What we're proposing to analyze here is to destroy soil. Somebody else might say the machine that we're going to use is super noisy and annoying the area. I don't know. So it could be many different things that the worsening part, like it can cause more other problems in a way if you think about it.
And please take into account that this is example. We prepare it to show you how a platform works.
Right.
Mm-hmm.
So once we have the contradiction in place, we want to define the next step, and we want to define the improvement parameter. And this is where we have the contradiction in front of our eyes all the time. In this particular case, we want to focus ourselves on the then parameter. So what is it we're improving, right? And the way that we try to force people to do that is by rewriting this worsening, this specific parameter in your own words again and again. So that forces people to think over and over again. That's important.
Let's take clean the field after the shooting.
So basically, the field will be clean eventually.
Mm-hmm.
Okay. So or we can also say there will no
debris.
The debris left. And so on, right?
Mhm.
Debris, how do I spell debris? Yeah.
Okay.
And so on, right? So we just defined it in our head, what is that parameter in our own words, right? Now, as the next step, once we have this parameter in our head, we have the 39 principles in here. And from mechanics perspective, once we choose any of these parameters, we have the explanation of what it is, what this parameter means. This is the official explanation that coming from Altshuler matrix at this point. And we can use it for an explanation to understand better what exactly that means. So area of moving object, here's the explanation for that. If we change to something else, it will be a different explanation, just to help us understand what it means.
So I would propose number 12, shape. Shape. And
Okay.
if you read the shape, it means, yeah. Yes, please.
An internal or external contour or profile of a component or a system as required for ergonomic and functional rather than aesthetical reasons. Okay.
Okay.
So also don't forget that when we trying to adopt the parameters, when we're trying to find the conceptual parameter or generic parameter, it's not always one-way street. We can play with it, we can change it and go back and forth as much as we want, and try different parameters that kind of make sense for that particular case. So let's say we decided to stop here on the shape. The next one that we need to go through exactly the same process, but for worsening parameter. It may destroy the field. All right. Let's
so
describe
it's everything which is we should be focused on everything which is written after but. Okay. Affected soil and changed the flora or of this area.
the soil will be affected. We might change the flora of the area. Area, etc. Okay.
Okay.
And same concept here. We have all of these 39 parameters that we need to choose from. And need to choose that means adopt or classify our specific parameter to one of these generic ones.
So I would recommend 26 quantity of substance. By the way, it's very keep in mind if you try to look for quality, which is very often people accept as a parameter, you will never find it. You should find something reasonable. By the way, quantity of substance is also somehow covers and quality. But if you read quantity of substance, the matter, it's exactly what
the amount, quantity,
about.
or a number of systems, materials, substances, parts, fields, or subsystems. Substance is used for most generic form of trees context and includes any physical or temporal thing, right? And of course, in here we're talking about substance or matter of the soil of the field itself, right? So we define these two parameters. Great. We have the improving and the worsening parameters. What's next? Right. Next, as a next step, we're not going to the traditional matrix, but this is coming from the traditional matrix, right? We got two parameters, two principles in here. In order, the order, again, it's important. We should analyze them. accordingly.
Okay.
Okay.
By the way, we have explanations. This is generic
Right.
explanation. You can, Alex, can you show me?
Yeah, just a second. So same concept as with parameters where we have an explanation for each and every one of them. This is generic definition of what it is, but we also collected some information for different applications. And for example, chemical engineering. Chemical engineering will have a little bit different, slightly different interpretation of what every principle means, right? Same for marketing and sales, right? A little bit different explanation. It means the same, it's a different interpretation, right? So that the way that I usually look at these things, I read the generic first, and then I read the one that in my field. In my field, I mean software, for example, in this case, right? And so on. So these different interpretations, they actually super helpful to think within our own field of view, and we're expanding these definitions more and more. Okay. Now, when we're reading these different definitions, this is where we need to adopt. That's the conceptual solution that statistically was found out there for this particular pair of parameters that we just chose. Now, how we can apply this conceptual solution for our particular use case, right?
So let's click record idea when we got an idea.
So
record
once
idea.
we get that, we're recording an idea. An idea, it means the concept in the platform was, let's not make people leave the platform or leave this particular page that we're working on and looking at, or force them write it on a piece of paper or in an email, God forbid. It's actually record an idea and forget about it and go for the next one.
So I would propose make targets from fertilizing material. Yeah, this is what came to me while reading explanation about blazing on this gas.
So, okay.
And another idea, you can record another idea. And another idea, you can make it from dog food, dogly, and and animals will eat it.
Or in fact, from any food, any animal.
Grass seed,
Animal
Soil
food.
would be
bird seed, and then you can shoot the birds.
the
But
soil
then you
would be
have-
full of debris from the animals.
Yeah, then you have another contradiction that you need to clean up the
maybe
leftovers
you-
after the animals.
Maybe you have another ideas. Please give another ideas. What you think, what you came out when you were reading about blazing on this gas.
Make it
But actually,
Make the
compostable.
clay targets from dirt.
Sorry,
Make the clay targets from dirt,
from dirt.
soil.
Excellent.
soil.
Oh, excellent.
Yeah, or compostable, which is similar.
Excellent. Fantastic.
dirt or compostable.
From chocolate, and kids will collect it.
Right,
Okay.
delegate the work to somebody else.
Okay, let's have a look on the phase transition. This is excellent. So let's read what's written. Phase transition.
Ice.
So phase transition already been told something about ice.
Eyes. Let's record this idea. Let's record this idea. Made from eyes.
Targets.
Is there
from
any
eyes.
other ideas? Are there any ideas? Other ideas? You know what is dry ice? Let's record the idea. We can do it from dry ice. And these
Isn't
dry
that the
ice.
same name?
Hmm?
In general? Isn't that the same conceptually? Dry ice
Conceptual
or
is the
regular
same.
ice?
Yeah, dry ice is from made from CO2, from carbon dioxide, and
Right.
this the ice cream is kept outside in with a dry ice.
Mhm.
And this dry ice will get phase transition, will get converted into CO2 gas, which is very good for trees. Do you have any other ideas?
We can use the hologram, for example, and use laser instead of bullets, so you don't have any
Oh,
debris at all.
Interesting.
oh, excellent.
What
You,
a video
yeah,
game instead of a real thing, right? Let's reword it. Play a video game and
Kind of, yeah.
yeah, instead of
No, but it's good.
well,
What Julie is suggesting is that we have reusable plates, basically.
Oh yes.
excellent.
okay,
Okay, great.
reusable plates, yeah, reusable targets.
Targets, yeah.
Yeah, but we still need to collect them.
Yeah. Okay.
And so
Okay.
on. And of course, these ideas are all collected in the ideas manager, where we can analyze them further and take the actions further. But in this particular case, again, we wanted to show the mechanics of how the inventive principle tool is working within the platform.
Alex, maybe you can show a report also.
Yeah. So in the report, the entire thing is shown as the entire project is basically reported, including the inventive principles that we just worked on and all the ideas that were just generated as a result of that. And it's actually surprisingly quite a few ideas just from a single tool. Right. And again, we wanted to focus on the tool itself today. And I'll stop here for any questions. We right on time.
I just want to add something. You can return back and forth and change and play with different parameters and get different recommendation, different principles. I love this this very much. And maybe one more interesting thing, we have a lot of blogs in our site with real examples of solutions made with 40 principles.
Will the
Yeah, go ahead.
will the report show all my attempts on finding the but sentence, the worsening parameter?
The report currently shows the last state, plus all the ideas that got generated as a result of that. Now,
I can keep
again,
it and try another one.
you can keep this and try another one if you want to keep a record. In general, we do have a record of which parameter was used, which principle was used to generate a particular idea. We do have that information, right? We do keep that information. We're not showing it here in the report, but we do have it. So potentially we can expose it if it's important in the report, in the platform itself, including in the ideas manager.
Thank you.
But
But
overall,
you got again into the platform, into the tool.
Yeah. So what I wanted to show that the report will show the last state, right, or of any tool.
But Alex, but again, if you wanna make additional analysis, you can get again into 40 principles, and it will also be documented
Right.
in the report. You click again.
So if we create another instance of this tool and we want to reuse this tool again, some other solution. Oops. And we continue further and we can analyze a different contradiction. And of course, we're going to get different parameters and so on. The report will have both of them.
Yeah.
Right.
Exactly.
And it was, in a way, it was done on purpose because that's how people think. They try, they try and try again. So this is the simple one. And of course, when there is nothing matching the principle, list of principles is everything from the beginning. And by the way, this is one of the rules probably in inventive principles, and also in the from the Altshuler matrix. In some cases, we don't have rules that matching anything. We don't, like, we end up in the let me go back to here. In some cases, we're falling into emptiness. There is nothing defined. In that case, we should basically start from the beginning, from the most used one, segmentation and so on. And people have more comments. Okay.
What about a tool that can merge different definition of contradiction? So if you have 5 different contradiction, something that merge the principle suggested. Because, for example, I have an old Excel file that can, first of all, solve the problem that I see, that the not symmetrical being of the matrix, and also merge together the result of several contradictions, because sometimes the very high level of abstractness of the principle, you are not sure if one principle or another. I simply put both and have maybe I'll show you in a different moment my Excel file that I found very useful, and my students also.
Okay.
Yeah.
I think I need to understand more.
Yeah,
exactly
it's
what you mean.
something very easy to understand once you see it.
Okay.
My poor English is
more than happy to look at this. More than happy to look into this, and more than happy to look at any ideas to improve this, because at the end of the day, we're building this tool to improve engineering thinking and improve engineers eventually, the engineering community.
Sergio, by the way, the main purpose of this tool, all this tool, is generating ideas. And in the very end, you see the list all ideas in the idea manager. And you can think again, you can rank it, you see rank all ideas, and you can apply round robin ranking. And this will make you think again about each solution. And doesn't matter from which contradiction it comes from. The idea is to find good ideas. By the way, I'm conducting lectures in university, in Ben Gurion University, and I saw how students just say, wow, when they got to the principle, they start to read it, and suddenly they say, oh, I know. It's just fantastic to see. And this is, I would say, very strong tool, which helps to be focused and think. Alex, maybe it's good to show where is our
I'll stop
blocks.
just a second. I'll stop the recording for now at this point.